Okay, so today's lesson is on moments at work, and we are going to define the term moment, describe what the moment of a force measures and how to increase the moment of a force, and calculate the moment of a force and explain why levers are force multipliers. So, the keywords are moment, load, effort, and force multiplier. And your starter is over here, so look at the image below. Would you be able to remove it using only your hands? What could you use to help you? So this image here. So pause the video here, jot a few ideas down, just to wake your brains up a little bit, and then we will continue with the lesson. Okay, so what is a moment then? Let's look at this. So let me just put all this up. So forces that act on objects that have a fixed point, such as the hinge of a door or a seesaw, may make the object rotate, and we call the turning effect of a force the moment. So moment is a key word that you need to know for this lesson. The fixed point is often called the pivot or fulcrum. Just pay attention to pivot, really. That's another key word that you need to know. And here's an example of a moment that we'll look at in the next lesson. It's gears going around. So that is one example of a moment. If a nut on a car wheel is difficult to undo with a short spanner, a longer spanner will help. Why do you think this is? And elderly people or people with arthritis can find it difficult to turn taps on and off. Having taps with long handles make it easier for them to turn the tap. Why do you think that is? So have a think about those two questions, jot down some ideas, and I will check your answers when you submit your work, but also we are going to hopefully rectify some common misconceptions about this as well. So pause the video here, jot some ideas down, and then come back. So if we look at spanners then, so here we have a spanner and it is undoing a bolt. So you cannot undo a tight bolt using only your hands, as I asked you to look at in the starter. So hopefully this should be helping you come to the correct conclusion on that, if you hadn't already. The spanner exerts a much larger turning effect on the nut than the force you apply to the spanner. So if you had to choose between a long-handled spanner and a short-handled spanner, which one do you think you would choose and why? So jot that down really quickly and answer this question, and then we will go through it. Okay, so the longer the spanner handle, the less force you need to exert on it to loosen the nut. So when unfastening a bolt, it is easier to use the longer spanner than a shorter one. The spanner is an example of a lever. So this is one example of a lever, and we'll go into more examples later. Okay, so here we have a crowbar that is lifting up a safe. So crowbar is a lever that can be used to move a heavy object such as this safe here. The weight of the object is called the load. That is one of your keywords from earlier. Remember that from the keyword list. And the force you apply to the lever is called the effort. So the load is the weight and the effort is the force you apply. So there is your effort. That is what you are applying. And the load is the weight. The effort needed to lift the load is only a fraction of the object's weight. The lever used in this way is an example of a force multiplier. That's another keyword, because the effort moves a much bigger load. Now, do you think you would choose a long crowbar or a short crowbar to lift a heavy weight such as this safe, and why? So remember back to earlier about the the spanner, and relate it to that. So the best course of action here would probably be a longer crowbar, because you could exert less force, you could put less force into it and it would do more work for you. So to calculate moments, to work out a moment you need to know the two things, and these two things are the force or weight, and the distance from the pivot. So you've got the distance here and the force. Okay, so this is how you would calculate a moment. So a moment is the force times the distance. So this is the equation you need to know, and I'm also going to show you the abbreviated equation as well. So here are your units. You've got Newton meters, newtons, and meters. So Newton meters is for the moment, so it's Nm, a big N and a little m. And then force, of course, is newtons, as you would know from previous lessons, and distance we do in meters. So that is why we end up with Newton meters, because it's force times distance. And this is your abbreviated equation. So m equals F times d. So you might see it in this form in exams. You will be expected to learn this equation. You will need to know this equation for your exams. So please write it down, put it in a highlighted box, make it very visible so that you know where it is. So if we look at this diagram here, we have 10 newtons here and 2 meters there. So you do 10 times 2, which is 20 Newton meters. So that is for that one. And for this one, it is 1 times 20 because it's 1 meter from the pivot, and 20 newtons is the force. So it'll be 20 times 1, which is 20 nanometers. Not nanometers, Newton meters. So, quick test of your understanding. So this diagram shows a spanner being used to turn a nut. So this one here. And the moment being applied is, so you choose from these, A 90, B 2400, C 240, or D 24. So remember you do your force times distance to figure out the overall moment. So your force would be 80, for example, and your distance would be 30 centimeters. And do that in meters. You need to convert your 30 centimeters into meters. So what would that be? And then you study these diagrams carefully and choose the one with the biggest moment. Now, this is more of a challenge for you because we haven't looked at gears yet, but you might surprise yourself and you might figure it out. And it's only a quick test of your understanding anyway. So have a go and come back for the answers. Okay, so here is your equations. It's force times distance. And 30 centimeters, what is that in meters? Well, 1 meter is 100 centimeters, so that would be 0.3 meters. So then you take 0.3 meters and times it by 80, and you should have 24 Newton meters. And the next one, study the diagrams carefully and choose the one with the biggest moment. That is C. And we will go through this more next lesson when we go through more examples of moments such as gears and more levers. Okay, so here's another example of how to calculate moments. So the word equation is written as symbols, which is m equals F times d, and m is the moment of the force in Newton meters, which is Nm, and force F is the force in newtons, which is N. D is the perpendicular distance from the line of action of the force to the pivot in meters, which is in M. For a worked example, we're going to use this one here. So a force of 50 newtons, so that would be there from the hand, is exerted on a claw hammer, this hammer, of a length of 0.30 meters, which is shown in figure 4. Calculate the moment of the force. You do the moment of the force equals 50 newtons times 0.30 meters equals 15 Newton meters. And you should have figured that out in the previous question as well. So the question I just gave you. So I'd like you to try this. So I've got 3 different things here. So we've got 5 newtons and 0.5 meters, 4 newtons and 0.4 meters, and 4 newtons and 0.25 meters. And here's your equation at the top if you don't have it already. but I'd like you to try and calculate the moment for these three things and then come back with the answers. Okay, so the first one, the moment is 2.5 Newton meters, because you would do 5 newtons times 0.5 meters. For the next one, you would do 4 newtons times 0.4 meters. And that would be 1.6 Newton meters. And the last one, you would do 4 newtons times by 0.25 meters. Which would be your 1.0 Newton meters. And that is the end of this lesson. Next lesson is going to be a continuation from this one. So we're going to look at levers again and gears. So I will see you then.